Good morning, everyone. Here is Dr. Girish Kumar, Associate Professor of Baby Raju Institute of Technology. So I'm working for Electrical and Electronics Engineering Department. So today I going to present about the course overview of electric vehicles. So starting from the course description, let us see the prerequisites of this course. So basically, we need to have the understanding of electrical circuits, electrical machines, fundamentals of electric drives for the complete course structure of the electrical vehicle course. So coming to the chapter one, it covers the basic fundamentals of electric vehicle design models and overview of conventional vehicles and the comparison of different vehicles like ICE and EVs, HEVs. So what are the different models can be designed? So that comparison made with the conventional vehicles for making like advantages and disadvantages to discuss about the EVs. Also, we discuss here about the basic components of electric vehicles, the list of components and their operating functional principles. Also, the policy roadmap of India, the initiatives taken from the government of India to promote the EVs and the dynamics of vehicle motion, the different dynamics like aerodynamic drags and vehicle resistance and the vehicle weight, dwell to well efficiency, and all we will cover in this particular chapter. Yes, let us come to the chapter 2. It is a propulsion unit. So basically, we know that the propulsion unit consisting of driving wheels, the motor, and the power source. So the here are different types of motors can be discussed here. So here basic motors that can be used in the electric vehicles have been listed here. The types of electric motors. So first one is a series motor. So this is a DC machine. Second one is a brushless DC machine. Third one is PMSM. Fourth one is AC induction motor. And fifth one is special reluctance motor. And also the current applications of these motors, which are useful for the electric propulsion unit, we'll discuss in this particular chapter. So coming to the chapter 3, here we discuss about the energy storage technologies. So then basically we know the battery is an electrical energy storage technology. So but here the according to the applications of different types of EVs and the EVs uh, more like capacity and its power requirement, we use a different types of batteries so that those type of batteries and their pros and cons, everything we'll discuss here. So basically the batteries what we use here is lithium ion batteries and lithium instead of lithium ion batteries the before the invention of the lithium ion batteries there were some batteries like lead acid battery and something, so that's dry batteries. So then the later versions also there like fuel cell based and ultra capacitors and the flywheels, and all together we discussed in this particular chapter. And also the state of the battery, like what is the charging state and what is the discharging state and what is the depth of discharge, there's the health conditions of the battery and that different parameters of the battery pack design and particular parameters we analyze here in this particular chapter. Coming to the fourth chapter, here we discuss about the electric vehicle drivetrain. So here in the drivetrain, different types of drivetrain topologies have been designed. So particularly in case of like uh, drivetrains of HEVs, hybrid electric vehicles. So we combine the IC engine with electric motors. So then combination can be have three models: the series design, parallel design, and series parallel combinations. And also their pros and cons will discuss, and the advantages of using which model is more efficient, as which model is less efficient, and for which particular application. Those things we discussed in the electric vehicle design of this drivetrain. And also we discuss about the drive regenerative braking model, so which is most predominant braking for the EVs, and how the braking can be applied, and how the energy like reverse back to the power source from the wheels through the regeneration. Everything will cover here in this particular chapter. Also, last and least the topic is the sizing of drivetrain system. So what like how optimally we can able to design a drivetrain model. So then that optimal parameters we can estimate here, along with a like a choosing of motor and a choosing of differential, a choosing of power converter, and all everything we discuss in this particular chapter. Coming to the chapter 5, this chapter 5 covers the mobility and the E connectors. So the E connectors we also call as the AV connectors. So these are very very important. The charging and like the power rating of this particular charging speeds will be like directly depending upon the type of convert connectors that we are using. This also called as a AV connectors or charging connectors. There are different types of connectors like level 1, level 2, level 3. Also the AC fast charging or DC fast chargings. In AC actually this is slow chargers only, but in that also we have three different categories like this level 1, level 2, level 3. So then DC is ultra fast charging, which will take very less time to charge. So like AC is a domestic and DC is nothing but just a commercial applications, like so we can have it as an outstations also. So that we will discuss, and different types of charging connectors offered by different companies and their pros and cons will discuss in this particular chapter. So then coming to the course outcomes, there are five outcomes for that particular course, and each outcome is covering each chapter. So the total five chapters if you cover, and you can achieve this five course outcomes. Thank you.